Hi guys, welcome back. We're going to go through the next page now on circumference. Now in question 4, it wants us to work out the circumference of these circles just like the previous questions, but it has this little extra bit at the end. It says leave your answers in terms of pi. And this is how examiners get around being able to set circle questions in a non-calculator paper. The other reason for leaving answers in terms of pi is that it means they're still exact. The minute we use pi and we round it like we have done on the previous pages, the answer is no longer exact, it's been rounded. Whereas if we just leave pi, this number that goes on and on forever, as a symbol in our answer, it means that the answer is still exact. So for pi, I'll show you how to do this. We've only been given the radius, and of course the formula for the circumference needs the diameter, pi times the diameter. So first we need to double the radius. So the diameter of this circle would be 4, and the circumference is therefore 4 times pi. And the way we leave this in terms of pi is just to remove the times sign and just say that the answer is 4 pi, because remember in algebra, if two things are next to each other, it means they're multiplying together. We don't need to show the times sign. Okay, this one we've already been given the diameter, so we just need to times it by pi, and that will just give us 8 pi. This one will just be 26 pi, and the final one, we need to double the radius there. That would give us 3.4 millimeters, so 3.4 pi is the answer. And you can give units with all of those answers. Remember, the units for the circumference are just units of length, so this would be millimeters, centimeters, and for this one, centimeters as well. Okay, question 5, find the size of the diameter of each of the following circles. So this time they've given us the circumference and they want us to work backwards to find the diameter. So questions like this, I always like to work forwards first. So I know that the circumference is pi times the diameter. Okay, so we've got circumference is pi times the diameter. So if I put in the things that I know here, I know the circumference is 12. I know pi, but I'm going to leave it as the symbol pi, and it's the diameter I want. And to find the diameter, I need to divide by pi. So I'm going to do 12 divided by pi, and that'll give me my diameter. So 3.82 to 2 decimal places. Okay, part B, the circumference divided by pi is going to give me the diameter. So 50 divided by pi is 15.92. And finally, 3 divided by pi is 0.95 meters though this time. Okay, question 6, find the size of the radius for each of the following circles. So same question, just finding the radius rather than the diameter. So we're going to find the diameter and then we're just going to halve it. So exactly the same as what we've just done. We're going to divide the circumference by pi, then we're going to halve it in a minute. So there's my diameter, 25.46, etc., etc. I'm just going to do the dividing stage now, and that gives me 12.73. Okay, so the way you could write this in the working is to say that that would give you the diameter divided by 2, 12.73 centimeters. Okay, and do the same thing on this one. 42 divided by pi would give me the diameter. 13 point something. And then I'm going to divide by 2 straight away. If you do it on the calculator like that, you don't lose much accuracy. So 6.68 meters. And then the last one, 2 divided by pi, and then divide that by 2, we get 0.32. Okay. Okay, number 7. A bicycle wheel has a diameter of 62 centimetres. The wheel makes 80 complete revolutions. Now, a revolution is 1 full turn. If any of you have heard of RPM, that means revolutions per minute. So the wheel turns 80 times in full. How far has the bicycle travelled? Okay, well, if I was to take a point on the wheel, for example, where the valve is there, look. Okay, imagine that was on the ground. Let me turn this upside down for a second. If I were to roll the wheel so that the valve moved around the wheel, the next time it touched the ground, the wheel will have travelled the distance of the circumference. Okay, so imagine actually if you cut the wheel right here and it were to unroll perfectly, the length it would unroll would be 1 circumference. Okay, so every complete turn is 1 circumference travelled. So we have 80 circumferences travelled. So all I've got to do is work out what the circumference is using the diameter and then times it by 80. So the circumference is pi times 62. Which is, unsurprisingly, 62 pi is what my calculator tells me that it is. Might as well leave it like that for now. And then I'm going to times that by 80. And that tells me the answer is 4,960 pi. But at this point, I'm going to give it in actual numbers. So that's 15,582.3 centimetres. And then I'm going to divide that by 100 to give me the answer in metres. 155.8. Should be accurate enough. Okay. And the last question. Nicole is a wedding organiser. The guests are to sit at circular tables with a diameter of 180 centimetres. Each guest needs 70 centimetres around the circumference. Okay, so we've got circular tables, 180 centimetres across, and each guest needs 70 centimetres. So we're talking about a length of arc, 70 centimetres. Okay. There are 18 tables at the venue and a total of 145 guests are attending the wedding. Are there enough tables? Okay, well, what a lot of people do with this question, it's very tempting to do, is to work out the circumference of one circle and then immediately times that by 18 and then divide the answer by 70. Don't do that. The reason being that if it worked out that you could only fit, let's say, I don't know, 5.7 guests around a table, that's 5 guests. That's not 5.7. You can't put 0.7 of a person around one table and put the other 0.3 of them on another table. Okay, so you can't split people across tables, and therefore we can't add up all of the circumferences of the circles and divide that total by the number of people. We need to actually just work about, so going back to, let's say there's 5.7 people on a table, we need to then round down and just say that only 5 people can sit on that table. Okay, I don't know if that's the answer. Let's have a look. So we're just going to deal with one table. Let's work out the circumference of one table. And that'll be 180 pi which is 565.49 centimetres. Okay, that's rounded just to be accurate enough. Now we're going to divide that by 70 because each guest needs 70 centimetres, and that'll tell us how many guests we can fit around a table. Okay, so 565.49 divided by 70 gives us 8.07 blah 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 blah. Okay, which means you can't fit 8.07 guests around a table, you can fit 8 guests per table. Okay, so we multiply 8 by the 18 tables that are at the venue, and we get 144. And there are 145 guests, and we can only seat 144. So, no, there are not enough tables. Okay, whereas if you had added up all the circumferences of the tables and then divided by 70, I think you might have found that there were enough. Okay, thanks for watching, guys.